let's look at how to solve multi-step equations. So to solve an equation involving several terms, we collect variable terms on one side of the equation and constant terms on the other. So solve equations by collecting like terms. So on the left side here, I have 3x plus 2 is equal to 2x minus 4. So what I need to do is I need to start isolating my variable. The only variable I have in here is x. So I need to bring this 2x over. If I do, it becomes negative, and I need to bring this 2 over, constant 2, over, and it becomes negative 2, and I've done that here in this step. So on the left side, I have 3x minus 2 is equal to negative 4 minus 2. Performing the math, I end up getting x is equal to negative 6. On the second example, we have 7 minus 2k is equal to 8 minus 5k. Again, I just kind of drew what I need to do. I need to bring this constant over, and I need to bring this variable term over, because I need them to be on the sides of the equation. When I bring this positive 8 over, it becomes negative. It's a terrible negative sign. And then when I bring this variable term over, this negative 2 becomes positive. So on the left side, I have negative 8 plus 7 is equal to negative 5k plus 2k. So then negative 1 is equal to 3k. I need to isolate my variable by dividing by 3, both sides by 3, and I end up getting negative 1 over 3 is equal to k. Then we have 5 minus 3m is equal to negative 2 minus 2m. So I'm going to bring all my variable terms over to the left. When I bring this negative 2m over, it becomes positive 2m. When I bring this positive 5 over, it becomes negative 5. So my left side is now negative 3m plus 2m is equal to negative 2 minus 5. Negative m is equal to negative 7. Now, we don't want to have a variable just left as negative, so I can either multiply both by a factor of negative 1 or divide both by a factor of negative 1, as long as I'm doing it to both sides, and then I end up getting my positive value for my variable, which is, in this case, 7. When solving equations with brackets, we use the distributive property, then collect like terms. So finding the solution to 5 times y minus 3 minus, in brackets, y minus 2 is equal to 19. So distributing the 5 into the brackets, and then distributing this negative. I just wrote that there is a 1 here, but you won't always see it. We won't write that as a 1, but know that there is essentially a negative 1 there. So this negative affects the sign of each of these terms inside the bracket. So if I distribute 5 into this bracket, I get 5y minus 15. If I distribute this negative sign, this positive y becomes negative, this negative 2 becomes positive, and then I have equals 19 on the right side of the equation. I'm going to go ahead and kind of arrange my like terms a little bit here on the left. So I have 5y minus y minus 15 plus 2 is equal to 19. Then I'm going to take these constants and bring them over. So I have still positive 19, but this negative 15 becomes positive. This positive becomes negative. So I have all my variables on one side, all my constants on the other. 5y minus y is 4y. 19 plus 15 minus 2 is 32. I still need to divide both sides by 4 to isolate for my variable y, and then I get my y value of 8. So we're going to perform a solve and check. So I'm going to solve this, and then I'm going to check left side and right side. So I need to distribute into this bracket 2 times x minus 3 is equal to negative 3 times x plus 5 minus 6. So when I distribute it, I end up getting 2x minus 6, right? Distribute this into here, is equal to, if I distribute this negative 3 into this bracket, I end up getting negative 3x minus 15. And then this negative 6 simply stays there because it's a constant term. Now I'm going to bring all my variables on one side. I'm going to bring this variable over. The negative becomes positive. I'm going to bring this constant over. This negative becomes positive. So now I have all my variables on the left side, 2x plus 3x, which gives me 5x. Then I have negative 15 minus 6 plus 6. Well, these just kind of cancel out. So I'm left with negative 15. Again, isolating by performing the opposite operation. In this case is dividing by 5. I get my x value to be negative 3. Now when I go ahead and perform a check, I'm going to write out the left side of the equation, 2 multiplied by x minus 3, and then I'm going to substitute my x equals value, or my x value, into the equation where x is. So in this case, it would be negative 3 minus 3, which gives me negative 6. Negative 6 times 2 is negative 12. Okay, so the left side is negative 12 when x is negative 3. I now need to plug it into my right side. So again, stating the right side of the equation, plugging in where the value of x minus 3 is, performing the math. So the negative 3 plus 5 is 2. 2 times negative 3 is negative 6. We still have this negative 6 here, or minus 6. The negative 6 minus 6 is equal to negative 12, which means that both of these are the same. Therefore, the left side is equal to the right side. Quick last three examples here, right? I have 6x plus 3 plus 2x is equal to 19. All my variables on one side, all my constants on the other, right? And then sign changes as I cross. Oh, no, actually, no, it didn't, sorry. 6x plus 2x, that's already on the left side of the equation. And then I bring this positive 3 over, it becomes negative. So then I have 8x is equal to 16, and then divide both sides by 8, I get my solution, which in this case is x is equal to 2. Distribute 4 into x minus 3, I get 4x minus 12 is equal to 3x minus 7. Bring my variable terms over, I brought this positive 3x over, becomes negative. Bring this negative 12 over, it becomes positive. Collect my like terms, 4x minus 3x is 1x, negative 7 plus 12 is 5. And the last one, distributing this 3 into the bracket, I end up getting 6p plus 3 is equal to, distributing this into the bracket, 5p plus 5. Go ahead and bring my variable terms over. This becomes negative as well. 6p minus 5p is 1p. 5 minus 3 is 2. So when we're doing the multi-step equations, again, bringing all of the variable terms over to one side of the equation, constants on the other. When you're asked to do a check, you are not looking for the exact same answer as what you solved it to be. This is simply what you need to plug into the left side. You're going to get a different answer. But if you plug this same one in to the right side and get the same answer, then you know it is correct.